Hi guys, I'm going to work through some problems in lesson 5.5, and if you're having any trouble, hopefully seeing some examples will help. In the first problem, I have the absolute value of x is greater than 2, and so what I need to think about is that x could be greater than 2. That's one thing we can know. Or in case 2, x could be less than, I'll change the sign, and then make the number negative, less than negative 2. And so what I end up with when I graph this is open circles, x is greater than 2, and x is less than negative 2. So we can see that it is all of these distances out here and out here, they're equidistant from 0. And we have both cases happening at the same time. I've been struggling with how to make the circle stay and put this, actually enter it on my iPad, but I don't have any problem doing it on the computer. So hopefully you're not having problems. If you are, let me know. For number 2, it says write an absolute value inequality for the graph below and use x for the variable. So notice that we have an and here because obviously we have an overlap. And so what we're going to do is, let's see, it's called x. So we're going to say that not only is x greater than negative 6, x is also less than 6. And so I think we can put this together by doing this. Put the negative 6 there, put the x here, and then put the upper boundary there. That still says that x is greater than negative 6 and that x is less than 6. And so we could actually type that in like this. Negative 6, and then this, and then this, and this, I believe, just like that. Whoops, what did I type wrong? X is greater than 6. At the same time, x is less than 6. Oh, I had to use an absolute value. Duh. Okay, that's funny. Let's do this instead. Let's say that the absolute value, the only one with it is this, the absolute value of x is, let's see, if I say less than 6, in doing that I will also imply that x is greater than negative 6, just like we did in the last problem, and that should be true. Yay! Alright, because I messed that up the first time, I'm going to try another. So this time I am going to say that the absolute value of x and then I'm going to say is, is greater than 3. Oops, I don't want it to go there though. We want it to be outside, greater than 3, because that would also imply in the second case that not only is x greater than 3, but x is less than negative 3. So that should have both cases implied there. Very good. All right, problem number 3. Oops, there we go. Graph the solution to the inequality on the number line. Okay, so let's solve this. So one thing that helps me is to remember that less thans are going to be, ands, and greater thans are going to be or. I think of the less than as being more exclusive, so it's smaller, and the greater than as more exclusive, inclusive is a better word, so it's going to be bigger. I don't know, however you can remember that. That's something to have in your notes that I wouldn't mind you ever looking back on to check if you have that in your notes. So let's proceed here. I'm going to say case 1 is this: x plus 5 is less than or equal to 5. Straight up, just like that. Case 2, I'm going to go x plus 5 is less than or equal to negative 5. So now we have two things to solve. Minus 5, minus 5. X is greater than or equal to 0. Over here we're subtracting 5 again. X is less than or equal to negative 10. So if I put that on a number line, what's going to happen is x is closed circle greater than or equal to 0. And then down here, x is less than or equal to negative 10. And yes, that is an or, because it has little arms reaching out. Little arms reaching out are always or. There's no overlap. This is a union where it's very inclusive and it's a large solution set. Let's go back and see if I can't. Let's see, we had negative 10 and 0. This is what I'm having a little bit of a hard time getting my. I made it work one time, and then oh, maybe it's gonna work. This guy goes down here, the other one, negative 10. Oop. Okay, now I made it mad again. Oh, okay. I want that to happen. I want that to happen over there. Okay, maybe this is working. Okay, so now I'm gonna get another dot, and I'm gonna go down here. Oh, it erased. Okay, I'm not gonna mess with that anymore. Hopefully you're not having problems on a computer. If you're using an iPad like I am, we may have to talk. Let's look at number 4. So this has a less than or equal to. So that's going to be an and. We're going to be looking for some overlap. Remember, if we'd had this, that would be an or. But we don't have that right now. We're looking for this situation. So case 1, 6u minus 18 is less than or equal to 12. Case 2, 6u minus 18 is greater than or equal to negative 12. So if I add 18 to both sides, I get 6u is less than or equal to 30. Divide by 6. Did not divide or multiply by a negative, so I'm going to have u is less than or equal to 5. And then over here, 6u is greater than or equal to positive 6. Divide by 6 and get 6, or u is greater than or equal to 1. Okay, u is less than or equal to 5. And u is greater than or equal to 1. And you can see that where this one might have gone on forever like that, and this one might have gone forever like that, they overlap in the middle. That's why it's an and, so that should be fine. I should be able to choose a number like 2 and plug it in. The absolute value of 6 times 2 minus 18 is less than or equal to 12. 12 minus 18 is negative 6, but the absolute value of that is 6, which is less than or equal to 12. Yes, check. All right. I won't try to graph it for you, but I will solve one more just in case although I don't think it'll let me see another one. Nope, unless I try to graph it. So never mind, I guess. I need to figure out how to do that. So ask me for help if you are struggling with these, and we will keep working at it until you do understand.